Differential leveling is the process of measuring vertical distances from a known elevation point to determine elevations of unknown points. The most common methods to determine elevation are through the use of 1. A compensator type, automatic, and level rods, and 2. An electronic digital barcode leveling instrument with barcode rod. A thorough knowledge of leveling principles and proper application of methods and equipment will prevent costly delays and generate the needed results in accuracy. In order of preference and accuracy, here are the preferred methods of obtaining elevations. First, differential leveling. Control benchmarks, cross-section, and point elevations. Second, trigonometric leveling for a digital terrain model or DTM and 3D model. Third, indirect leveling, which measures horizontal distances and vertical angles. Fourth, three-dimensional coordinates. Both horizontal position and elevation are computed by processing the measurements. And the last one, GPS survey, given the appropriate equipment, procedure, and data collection.
The objectives of this fieldwork are first, to acquire and develop the skills of determining the elevation of a point from a benchmark of known elevation by establishing a single setup. Second is to acquire and develop the skills of determining the elevation of a point from a benchmark of known elevation by establishing multiple setup using turning points. Lastly is to develop the skills in using leveling instruments. Now let's move on to the instruments and accessories. The leveling rod, which is a vertically supported tape used to measure vertical distance, which is the difference in elevation between a line of sight and a required point above or below it. Auto level, which is an optical instrument used to establish or verify points in the same horizontal plane. Then the markers, which will be used to indicate a position. And lastly, a plumb bob, which is a weight with a pointed tip on the bottom that's hung from a string and is used for establishing a vertical reference. For part A, we have single setup differential leveling. A single level setup is shown in this figure. A backsight reading is taken on a rod held on a point of known elevation or the benchmark. That elevation is transferred vertically to the line of sight by reading the rod and then adding the known elevation and the backsight reading. The elevation of the line of sight is the height of the instrument or HI. By definition, the line of sight is horizontal. Therefore, the line of sight elevation can then be transferred down to the unknown elevation point by turning the telescope to the foresight and reading the rod. The elevation of the foresight station is found by subtracting the rod reading from the height of the instrument. Now for the procedures, the instructor assigns the location of 2 points marked as A and B, which are intervisible with the instrument setup placed between the points. Set up the instrument level on the suitable points, preferable about midpoint of the 2 designated stations A and B by driving the tripod firmly on the ground. Adjust the height of the instrument to the convenient level of the instrument man through tripod legs locks. Check the bubble in the vial of the level if it is in the center. If not, adjust the screws by rotating clockwise or counterclockwise. Take the backsight reading of point A where the leveling rod is being held vertical with the aid of the plumb bob. The reading must be done up to the accuracy of a millimeter or thousandth of a meter. Next step is to rotate the telescope after point B is in sight. Then, the rodman transfers the leveling rod at station B and must hold it with the plumb bob alongside to maintain the verticality of the rod. Now, you can take the foresight reading of the leveling rod, and again, the reading must be done up to the accuracy of a millimeter or thousandth of a meter. After recording the observed values, compute for the difference of the readings to determine the difference in elevation between benchmarks. Repeat procedures 1 to 8 for second and third trial. Now, you can tabulate the data in Table 4.1, Single Setup Differential Leveling. The difference in elevation from the backside station to the foresight station is determined by subtracting the foresight rod reading from the backside rod reading. To compute for the most probable difference in elevation or most probable DE, simply get the mean of all the obtained DE values.
For the second part, we will use turning points and benchmarks. Benchmarks are either points of established elevations or just reference points with assigned elevation, while turning points are intermediate points between your benchmarks which provides a temporary point of known elevation for a circuit between two benchmarks, and are used when the second benchmark can't be viewed by the precise level. The instructor assigns the location of another 2 points marked as A and B. Set up the instrument level on the suitable points, preferable about midpoint of the two designated stations A and B, by driving the tripod firmly on the ground. Adjust the height of the instrument to the convenient level of instrument mount through tripod legs locks. Check the bubble in the vial of the level if it is in the center. If not, adjust the screws by rotating clockwise or counterclockwise. Take the backside reading of point A where the leveling rod is being held vertical with the aid of a plumb bob. The reading must be done up to the accuracy of a millimeter or thousandth of meter. Rotate the telescope until the newly established point designated as turning point can be sighted. Ensure the turning point should be almost equidistant from the instrument as the first benchmark from the instrument. The rodman transfers the leveling rod at TP and must hold it with plumb bob alongside to maintain verticality of the rod. Take the foresight reading of TP where the leveling rod is being held vertical with the aid of a plumb bob. The reading must be done up to the accuracy of a millimeter or thousandth of meter. Transfer the instrument to another location along the route to BM2 where the first turning point is still visible in the telescope, and follow the same procedures as in 2 to 8 until you reach the second benchmark. Lastly, tabulate the data in Table 4.2, Differential Leveling with Turning Points. We already have the reading of our backside in point A from step 4, so we can put it here in this box. We can now simply compute the height of the instrument or the HI. Just add the elevation to the backside reading. Then in step 7, we already have our foresight reading in TP1, which we can put here in this box. We can now calculate our new elevation. Simply subtract the height of the instrument or the HI from the foresight or the FS.